All right, welcome to Chapter 5's last video and the last video of the school year. Lesson 5.6 and 5.7, we're going to perform function operations and composition of functions. All right, so here is operations of functions. So this is technically lesson 5.6. And what we're going to do is we're basically adding, subtracting, multiplying, and dividing functions. So all that means is we're going to be given two functions. So if you see it written like this, that means you're going to take the f of x, you're going to add it to g of x, just like they have an example here. And so these were what f of x and g of x is. So you're subtracting, you're going to subtract, just remember to distribute your subtraction sign. Multiplying, you're multiplying, dividing, you're dividing, and you simplify. Okay? So it says the domains of the sum, difference, product, and quotient functions consist of the x values that are the domains of both f and g. Additionally, the domain of the quotient does not include x values for which g of x equals 0. So we are going to be talking about domain and range as well. I'm going to skip this evaluating because this is goes with the next. No, this goes with the next part. You have combined functions by finding sums, difference, products, and quotients of functions. Another way of combining two functions is to form a composition. That's what we're going to do in lesson 7. So she put these, I didn't make this one, she put them on the same page, but that's okay. So we'll come back to this one when we get to these parts. All right, so let's just dive into adding two functions. All right, so it says let f of x equal 4 times 2 to the x power and g of x equal negative 3 times 2 to the x power. Find f plus g of x and state the domain, then evaluate when the function would be 4. All right, so we got a couple things going on here. All right, so we are going to set this up as we are adding f of x and g of x. So basically we are adding the highlighted parts. Okay, so we have f of x, I'll go ahead and write it down just so you have it, plus g of x is all we are doing. All right, and f of x is 4 times 2 to the x power, and g of x is negative 3 times 2 to the x power. So because these two are the same, so we could treat these like previous lessons. Because these two are the same, we could treat that like a common variable, and we can actually add this 4 and the negative 3 together. So we could kind of treat it like 4 plus negative 3, and those are both being multiplied times 2 to the x power, because these are the same. And so then we just need to add this together. Well, 4 plus negative 3 is 1. 1 times anything is itself, so definitely not necessary to write the 1. So we actually end up with 2 to the x power. So that's the first part. So this is what f plus g of x equals. It's 2x. So that's your first part. All right, second part, we have to state our domain and range. All right, so the functions of f and g have the same domain, all real numbers. How do we know that? Because it is an exponential function. Remember, exponential functions grow or decay infinitely. That was the word I was looking for. All right, so they go in both directions infinitely. So your domain, if you added both of those together, would be the same. So that also is all real numbers. We don't have to state the domain, we just have to state the range, we just have to state the domain. So all real numbers. And if you need to make a note because they're exponential functions, whatever you need to help you to know, so that the domain is all real numbers. All right, so next thing we have to do is evaluate f plus g of 4. Well, f plus g of 4 is equal to 2 to the 4th power. So we're taking our function, we're replacing x with the value, and if you did 2 to the 4th power in a calculator, or 2 times 2 times 2 times 2, you would get 16. So f plus g of 4 is equal to 16. So You're simply adding them together. And if all else fails, if you're not sure about the domain, remember, you have a graphing calculator. Put these two functions in the graphing calculator. Look at how your graph exists across the x values. If they're both going to infinity in different ways, then you know that's all real numbers. All right, so let's subtract some now. The important part with subtracting that most people make the mistake is you have to subtract the entire thing behind it. The entire thing behind it. I see many a times where you guys subtract the first term and then you don't subtract the rest, your answer's wrong. So same idea. We're taking f of x and we're going to subtract g of x. So I'm just rewriting f of x, 3x cubed minus 2x squared plus 5. Now I'm subtracting this whole thing. If you want to go ahead and change your signs from here, you can, but for note purposes, I am not at this time. All right, so what I mean by this is this negative, just like we did in chapter, I think it was 4, which would have technically been the chapter before this had they not made us go out of order. We have to distribute that negative to every single term. Many of you will stop here. Please don't stop there. So I'm going to write the first ones down. I don't need to do anything with these. This becomes negative x cubed. This becomes positive 3x squared. This becomes negative 4x. And this becomes positive 2. Now all I have to do is combine my like terms. All right, so what terms do I have that are alike? I have this negative 2x squared, and I have this positive 3x squared. Whoops, sorry. So those two are alike. I have this 3x cubed and this negative 3x cubed. Those two are alike. And I don't have another color, so we're just going to circle those. And then we have the plus 5 and the plus 2. And the 4x is all alone, nothing to combine it with. So 3x cubed, if you need to put a 1 there, put a 1 there. What's 3 minus 1? 2. So we get 2x cubed. Negative 2 plus 3 gives you positive x squared. So the same as 1. If there's none, there's 1. Then we said there's nothing to combine the x with, so we're just going to say minus 4x. And guys, these should be in descending order. They shouldn't be all mixed up. And then our last one is 5 plus 2. That gives us 7. All right, so that is what f minus g of x equals. But they want us to state the domain. So if we look at this function, we have a odd function and we have an odd. So they are both cube functions, right? So if you remember, the graph looks a little something along these lines, right? And so the domain and the range for those kind of functions are all real numbers. So again, for this one, your domain would be all real numbers. And guys, your domain is all real numbers 70% of the time. So if you are unsure and you have no idea, 70% of the time, your domain is all real numbers. Your range changes more. All right, so now we need to evaluate f minus g when it equals negative 2. I'm going to draw a line here just so my numbers don't go together. So f minus g of 2 equals, now because I don't have much space here, I'm going to write down there. So we're going to this part right here. This is our final answer right here, and we're going to plug in everywhere there's an x, we're plugging in a 2. So we have 2 times 2 cubed plus 2 squared minus 4 times 2 plus 7. And then you're just doing your order of operations. So 2 cubed is 8, 8 times 2 is 16, 2 squared is 4, 4 times 2 is 8, and then we're just going to add left to right. So 16 plus 4 is 20, minus 8 is 12. Yeah? Were we supposed to do a different number? Oh, dear Jesus. Miss Gill, you and you're not paying attention. Can't believe you, lady. This was negative 2, so let's try this again. I'll be back. Guess I was excited about finally making the last video. All right, so I'm going to break this down a little more. Negative 2 to the third power. Anytime you have a negative raised to an odd exponent, it's negative. 2 times 2 times 2 is 8. Then we have negative 2 squared. Anytime you have a negative raised to an even exponent, it becomes positive. Negative 4 times negative 2 is going to give me positive 8, and then I have positive 7. So 2 times 8 gives us negative 16. So we have negative 16 plus 4 plus 8 plus 7. So that becomes negative 12. That becomes negative 12 plus 8 is negative 4. Negative 4 plus 7 is 3. So f minus g of negative 2 equals 3. All right, multiplying. Same idea, guys. Same idea. Multiplying two functions. We're going to do just like it says. We're going to multiply them. All right, so we have f of x equals x squared. We have g of x equals x minus 4. So we're simply multiplying them together. So we're going to say f of x times g of x. So what is f of x? It is x squared. What is g of x? It is x minus 4. So we're just going to distribute. All right, x squared times x, add your exponents, we get 3. X squared times negative 4 gives us negative 4x squared. So that is what fg of x is. All right, so then we have to state our domain. So our domain, again, if you are unsure about your domain and range, graph these functions and look at it. We know that a quadratic function, the domain is always all real numbers. A linear function, the domain is all real numbers. So guess what? Your domain is all real numbers. Hey, we're shooting 3 for 3 that the domain is all real numbers. We have one more. So right now, even if this one isn't, we have 75%, right? Okay, so let's multiply away. We already did. It's been a day. It's been a day. Bear with me. All right, so we stated the domain. Now we are finding f times g of when it is 3. So everywhere there's an x, I'm going to substitute in a 3. So I got 3 cubed minus 4 times 3 squared. Remember, PEMDAS, exponents before multiplication. So 3 cubed gives us 27. Minus 4 times 3 squared is 9. So 27 minus 36. And that would equal negative 9. So f times g of 3, didn't mean to put this there, equals negative 9. And that's your answer. All right, we have one more. Dividing. Dividing two functions. So with division, remember asymptotes sometimes come into play with our denominators. So that may be the case with this one. So basically, we're just dividing f by g. Okay? So basically, we're saying f of x over g of x. So what is f of x? 2x plus 10. G of x is 6x. So we can factor. These two have a 2 in common, so we can factor that out. And then I could actually rewrite this as 2 times 3x, right? Because then I could cancel out the 2's. So then the 2's cancel each other out. This is from chapter 7, so maybe it's a good thing we did do chapter 7 before 5. Who knows? And then we end up with x plus 5 over 3x. So our domain, okay? So this one, it's a linear function, so your domain is all real numbers. Linear function, domain is all real numbers. However, like we learned in chapter 7, if your denominator equals 0, it creates an asymptote. So what value of x would make your denominator 0? So 3 times x equal to 0, what would that be if x was 0? Right? So you have to put that in your domain. So our domain is all real numbers. However, if we were to graph this, it would give us an asymptote at 0. So we would say, except x cannot equal 0. So it's all real numbers except 0. So now they want us to substitute in 16. So we're going to take our function and we're going to find out when it's 16. So 16 plus 5. Everywhere there's an x, we're going to put in 16. 3 times 16. So 16 plus 5 gives me 21. 3 times 16 gives me 48. Can I simplify? So I can. They both can be divided by 3. 21 divided by 3 is 7. 48 divided by 3 is 16. And so that would be your answer for that one. So these aren't too complicated in my opinion, but you know, I am the teacher and so the student. So I would like for you to try these. And you are letting f of x equal this, g of x equal this. You are finding f plus g of x, f minus g of x, and then when those values are 3. And then with this one, you're doing multiplying and dividing. So yes, I would like you to try both of them. So if you will please pause the video, give both of those a try. So then plugged in -3 and added together, got 37. They are both, that one's a linear, which is all real numbers for its domain. That one's quadratic, which is all real numbers. When you add it together, nothing changes, so its domain is all real numbers. All right, subtracting. So in this case, we only had the one term, so we didn't have to worry about distributing that negative. But remember to do that if you have more than one term. So again, I just moved this to the front to make it in descending order, substitute in -3 and got -17. All right, again, both linear and quadratic have all real numbers for the domain, and so therefore subtracting them would keep the domain the same. Multiplying. So the multiplying one was a little ugly. It was all right. I don't know why they did it like this. They could have worked it out for us. You could work this out ahead of time if you wanted to. Remember the pattern a plus b squared is a squared plus 2 times a times b plus b squared. Or you could do box method. Since these are being multiplied, doesn't matter the order in which you multiply, your product will be the same. So I went ahead and multiplied it. Could you distribute then multiply? Yes, you'll end up with the same thing. So you get 9x cubed plus 18x squared plus 9x. You plug in 5, you get this beautiful number, 1,620. All right, again, I forgot to write it on here, but when multiplying, your domain would also be all real numbers. All right, this one, we are setting up f of x over g of x. They both have a factor of 3, so I divided that out, and we were left with x over x plus 1 squared. Don't think too much into these. All right, don't think too much into these. So what value of x would make our denominator 0? -1. Again, maybe that's why they did put chapter 7 in front, because we learned that in chapter 7. Anyways, moving on. So the domain would be all real numbers, except we would get an asymptote at -1 because -1 plus 1 is 0, can't divide by 0. So all real numbers except -1. And then if you plugged in 5, you would get 5 over 5 plus 1, which is 6. 6 squared is 36. So hopefully you gave those a try, and hopefully you feel good about those. We are going to move on to the next part, which is the composition. I am going to end the video here and pick it up as a new video. So there is a part 2.